29 through 36. Please choose 29 through 36 on page 338. So let's choose something that catches your eye. Of course, these are totally different from the ones we looked at before. So let's choose one. I'll choose 31, and then you can choose another. E to 4x plus 4e to 2x minus 21 equals 0. So what can we do here? What do you think? First, we are asked to solve for x. So what will be our first step? Wonderful. Awesome. So you're going to say, I'm going to denote this by blah. And then this will definitely be
Blah squared.
Thank you. That does it. Good. Why? Because it's easier to factor. Awesome. Okay, did everyone hear? Quadratic in form. Okay, perfect. T squared plus 4t minus 21 equals 0. So actually we said let t represent e to 2x. Awesome. Now this I know how to factor. Very good. So then we do have two values of t. And those values of t are t equals
7 and t.
Careful. Negative 7 and good. So now we created two new equations. Can anyone give us those two new equations? E to 2x equals
-7.
Excellent.
And e to 2x.
Very good. Excellent. Good. So now let's see. Does anyone remember the graph of e to the x or e to 2x or e to the positive x, in other words? Fastest growth possible. Okay. Does anyone remember the graph of y equals -7?
Plus 0.
-7 is -7. So here is e to the x. Exactly. And I cannot apply log to both sides because this is a negative number. The domain of log specifies 0 to infinity. So no solutions. So in other words, if I graph the left-hand side, I graph this. And a horizontal asymptote y equals 0. If I graph the right-hand side, I graph this. And how many points do they meet?
0.
None. Very good. Okay, the second one is possible. What do I do? No, no. I apply natural log to both sides. Why natural log and not common log? It doesn't matter, but because it's e, it's better to apply natural log. So then, a very important property characteristic to log allows me to do this. So 2x times natural log e. But how much is natural log of the base, in any base? 1. Excellent. So this is natural log 3. Therefore, x equals, and it's the only solution, x equals. I cannot separate these two. So the top is natural log, and everything divided by 2. That's it. And you can approximate it, the calculator, if you want to. Do we want to choose another 29 to 36, or we move on?
So for 34,
Yes?
you just have to make it equal to 1.
Let's take a look. Yes. 34. X squared times 10 to the x minus x times 10 to the x equals 2 times 10 to the x. Yes. Suggestions?
We pull out 10 to the x.
Yes. Why would I be allowed to divide by 10 to the x when I said to you many times before, you cannot divide both sides of an equation by something or an expression that contains the variable. But I am allowed to divide here by 10 to the x. Okay, let me explain the difference. Very important. If I have something like x cubed minus 2x squared equals 0 and I divide both sides by x squared, that would be a terrible mistake. How many solutions does this equation have? 3. Let's say I make the mistake of dividing both sides by x squared. How many solutions will I only get now? 1. And that is not allowed. But here, why? Why? Because x can be 0. X can be 0 and I divide it by 0 actually. Because x can be 0. So that's why I can do that. But I can divide by 10 to the x because this is never 0. Ever. So if, let's say, I don't divide by it and I factor it out, 10 to the x, and then I have x squared minus x minus 2 equals 0, then I will say, okay, I have two options. 10 to the x to be 0, but that's never going to happen. And the other option is x squared minus x minus 2 equals 0, which I would have gotten if I had divided both sides by 10 to the x.
Okay, so either way it's right?
Yes.
Okay.
Only because 10 to the x can never be 0. So in other words, 10 to the x is not a possible solution. Here, x can be 0. And x equals 0 is a possible solution that I excluded by dividing both sides by x squared. So this equation has 3 solutions. 2 are the same, x equals 0. And we know that that's a major issue. It's a term. Multiplicity 2. I can exclude this option, 2 of 0. And the third solution is 2. That's why I'm not allowed to divide by x squared. Because I have to have 3 solutions. But here, 10 to the x, remember the graph? This is 10 to the x. Is never 0. So even if I don't divide by it, it's not going to give me an extra solution. Is that clear? Okay, so now I have to solve this. How do I solve this? Yes. How? So I'm being spoon-fed a little bit. Very good. So then one solution is 2 and the other one is -1. Very good.
So when you divide by 10x,
10 raised to the x.
raised to x, yeah.
It's a difference. It's not 10 to the 10 times x.
Yeah, yeah.
Right.
So there's still a 10 to the x in front of x squared minus x?
Yeah. All terms have 10 to the x. Otherwise, I would have not thought of dividing.
Right. If we
And actually, I didn't divide. I moved this term to the other side and I factored out 10 to the x.
Oh, okay.
But it doesn't matter. I could have divided from the beginning because 10 to the x does not bring a new solution. I'm not missing anything by dividing by 10 to the x. But here I'm missing terribly by dividing by x squared. I'm missing what? 2 solutions. Okay, let's move on to logarithmic equations now.
So
Yes.
is x equals 2 and x equals -1 the answers?
That's it?
But can, oh,
Yes, we can check. You want to check?
No, I see. No, I'm tracking. Now.
Yeah, we can go back and check. Is that okay?
Yeah, I got it.
Good. When we solved exponential equations, and we had many, right? We had many equations. We had this one, which was not simple. We had all sorts from here. We had a situation like this. We had examples from here. Did we state any restrictions? No. because the exponential function is or is not friendly.
Is
Right. It's not going to happen with log. So when we solve log equations, we have two options. It's very similar to solving radical equations when we square both sides or cube both sides. But we have to do go back and with radical equations. Go back and check, right? Because the principle of powers can produce solutions that do not work in the original problem. Here we have two options. So solving log equations require us to choose from. You do not have to be consistent. What I mean by that is you can solve one logarithmic equation using one method and the next one using the other method. You don't have to stick with one particular method forever. But you have to make sure that one or the other is applied in any case. So one possibility is check solutions in the original problem, of course. Check solutions in the original equation. The second option is state domain and check against the domain. You'll see in a minute what I mean by this. Which one do you think I will go for?
domain.
Yes, it's easier. However, sometimes checking solutions will be easier. But most of the time, I think stating the domain is easier. Now, also, I know at least some of my flaws, and one of them is I may forget to go back and check. But if I state the domain, I will not. Or the chances that I will forget to go back and check against the domain are less. Okay, but that's me. It's up to you. You choose the method. Okay, so let's take a look on page 338. And let's start with 40. So log of x minus 4 equals 3. I don't see a base. What will the base be here?
10.
Yes. If there is no base, the base must be 10. Very good. Okay. So now, what is the domain of this function? What do I have to write? Greater than 0.
Yeah, greater than 0.
Yes. X minus 4 must be a positive number, otherwise log cannot be applied to it. So this is good enough. So I need to make sure that whatever I get is a number greater than 4. If what I get is 5, it's good. If I get -1, it's not good. Okay, that's all I need to know, to remember. Okay, so then I know I have no idea how to solve this. But I know I can change it into an exponential equation. How? Counterclockwise. I start with the base and go counterclockwise.
10 to the third.
Equals?
X minus 1.
Good. How much is 10 to the third? 3 zeros. 1,000. And I have to add 4. So x equals 1,004. Is this in the domain?
Yes.
Good. That's it. Done. That's it. Okay. Let's look at 44. Log base 2 of x squared minus x minus 2 equals 2. You can say, I don't feel like finding the domain of this function. What will I have to write to find the domain?
X squared minus x minus 2.
Right. Because this is quadratic and you taught me to use that chart and I have to factor. And so for this one, I want to check. So I'll make myself a note, must check. Oops. So because it takes longer to find the domain of this function, correct? Okay, so then now I will convert it. How do I convert it? I don't know how to solve this.
2 squared
Yes.
equals x squared.
2 squared equals x squared minus x minus 2. So then x squared minus x minus 2 minus 4 equals 0. And x squared minus x minus 6 equals 0. Okay. I have it in my mind. I must check. It's a must. I was too lazy to find the domain, but I can't be lazy when it comes to checking.
Okay.
The sum is -1. If I put minus 6, the sum,
Minus 3
yes,
x plus
and x plus 2. So there are two options. X equals, x equals.
x equals 3 and x.
I have no idea whether they work because I was too lazy to find the domain. So then I have to go back and check. So I'm checking 3. How much is 3 squared? 9 minus 3. 6. 6 minus 2. 4. So I'm asking myself now, is log base 2 of 4 2?
So 2 squared equals 4.
2 squared equals 4. I will say yes next to 3. Okay, now let's try -2. -2 squared is 4. Plus 2, 6. Minus 2, 4. Log base 2 of 4 is 2. I will say yes again. Meaning, yes, I checked. Okay. Let's take a look at 50. I'll let you choose the next one in a minute. So log base 3 of x plus 15 minus log base 3 of x minus 1 equals 2.
You get how many domains?
Very good question. Yes. So let's write the domain for the first one. I have to write that x plus 15 must be good. And the domain for the second one, I have to write that x minus 1 must be good. So then this one is greater than -15, and this one is greater than 1. So greater than 1 is here, and greater than -15 is here. I have to choose where both are conditions are fulfilled.
So 1 domain.
That's it. If it's not here, it cannot be accepted. Good. So now I go back to the original problem, and I want you to tell me what to do next.
You say log base 3 of x plus 15 divided by x.
Awesome. Log base 3 of x plus 15 divided by x minus 1 equals 2. That's why we studied condensing in the previous section. Exactly. And now I can convert it.
Okay, 3 squared
Yes,
equals x plus 15 divided by x plus 1.
very good. And 3 squared is 9, or 9 over 1. And now you know why I put 9 over 1. To give you a hint. And what is the hint?
Cross multiply.
Right. So 9x minus 9 equals x plus 15. Or 8x equals 24. Or x equals 3. Is this in the domain?
Yes.
So it will be accepted then. Now feel free to choose anything you want from 37 through 58, and then we'll look at 59. See, the exponential and log functions, they came up with the fish population. A small lake is stocked with a certain species of fish. The fish population is modeled by this function. The atmospheric pressure, natural log. Cooling an engine, natural log. Electric circuits, exponential. Just everything. That's why that E is called natural. Comes into play everywhere. Okay, so please choose.
$48.
48. Log base 5 of x plus log base 5 of x plus 1 equals log base 5 of 20. Does log base 5 of 20 need a restriction? No, it's a number. How can I restrict a number? I can restrict a variable, but not a number. Good, excellent. So what is the domain of the first one?
X greater than 0.
How do I get the domain for the second one?
X plus 1 greater than 0.
So I graph them both to see where they intersect. Here is 0, and this one is x greater than -1. So what is the common domain? We need both colors, blue and red.
0, 2.
That's it. If I don't get a solution as being a positive number, not 0, of course, then I have to reject it. Okay, the left-hand side, please. Yes, I need to condense it. Log base 5.
So it's log base 5 x times x plus 1.
Very good. Now, we are not simplifying or dropping anything, so please watch for a second. I am told 2 logs in base 5 are equal. Log is a one-to-one function. I cannot find 2 different numbers whose logs are the same. So 2 logs in base 5 are the same. So what can you tell me about these 2 numbers? They have to be the same, right? So x times x plus 1 must equal 20, otherwise log of 5, base 5 of those 2 will not be the same. How do I solve this? What type of equation is it? Very good. So x squared plus x minus 20 equals 0.
X plus 5 plus 1.
So there are 2 options. See how elegant stating the domain is? I don't have to go to the hassle of going back to check anything. I can tell which one works and which one has to be dropped. Does the first one work? No. This is the only one. Good. Anything else, or we go to 59? There was a question. Parker asked a question about 59. We have to work on 59. Anything else?
Yeah, I got a question
Yes.
about 57.
57. Let's take a look.
Crazy.
I thought he was banned.
Not awesome.
Okay. That's the one I didn't want him to choose.
Really?
No, no,
Oh, come
I'm
on.
kidding. I'm kidding. I'm kidding. I'm kidding. So I think it's 2 over log base 5 of x, is it?
Yeah, I think so. Oh, you're right.
And that equals 1 over 16, correct? Very good. Good pick, actually.
But I
Not
was-
really. Good pick. I'm kidding.
Okay.
Okay. So here is when I look at this equation, this is what I see. I see 2 to some power on the left-hand side, and I see 1 over 16, which can be presented with the same base on the other. That's what I see. So the left-hand side is 2 raised to a power, whatever. I'm going to copy it in a moment. But how do I rewrite the right-hand side?
Equal 2
To which power?
to -4.
Excellent. Stay with me. I'm going to copy the power now. So it is very important to try to, when you look at an equation, to be able to decompose it in little pieces. Okay? So that's how I came up with that. Okay, so it's 2. That really hurts my eye, right? That power hurts my eye, right? I put this white out on it, and I said, oh, huh,
Can you use right now 2 over log of 5x equals -1?
there is no need.
Oh.
It's easier than that. You're on the right track.
Easier than that.
Why? Why? Because both sides have the same base. So then what has to happen to the exponents? Careful. Careful, careful, careful. 2 numbers are the same, and they have the same base.
You still don't equal each other, right?
Exactly. Exactly. There is no need for log. You can apply it.
Log.
You can apply it, but then these 2 powers have to be the same. Right? So 2 numbers are equal, and they have the same base. What should these be? If this is -4, this cannot be 10. This must be -4. Only 2 raised to -4 equals 2 raised to -4.
So the same thing as last time we just did pretty much, pretty lowest, right, 5.
No, this is an exponential equation. This is a log equation.
Yeah, but it's the same concept way of log base 5 go away. Did you set it equal to each other?
Yes, but exponential. Exactly. Yes. 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 Only because they had the same base. So there were 2 numbers were equal, right? And their logs in base 5 have to be the same, or vice versa. If their logs in base 5 are the same, these 2 numbers have to be identical. So here, if 2 numbers are equal and they have the same base, their exponents must be the same. Good. So now, here's my next hint for you. What will I do next? Cross multiply. So then I have 2 equals -4 log base 5 of x. It's not cleaned up yet. I need one more step to clean it up.
Divide by -4.
Correct. So I have log base 5 of x equals -1/2. And now,
Five to the 1/2 power equals x.
to -1/2.
Yeah.
Right. 5 raised to -1/2 equals x. And that's our solution. I can rewrite it as x equals, it's negative power, 1 over 5 to 1/2. But what is 5 to 1/2? Square root of 5. So I can also rationalize it. And then I have x equals the square root of 5 over 5. Very good pick. Now this time I'm not kidding. Very good problem.
Oh, okay.
Yes. Do we have anything else here, or we move on to 59?
Correct.
Okay, so 59. Okay, 59 then. You see the calculator symbol next to it? Before we go to calculus 1, we will not be able to solve this by hand. Yes, we have to. Okay. So before we do anything, of course I'm not ready. So we will denote the left-hand side, let's say by y1, and the right-hand side by y2, and we will use the feature, calculator feature that says intersect. It's called intersect.
Let's see,
So-
make it equal to 0.
Oh, you can. And then you will have, you're looking for zeros. That's another option.
Yeah, because
That's-
what I'm confused about.
That's fine. You have two options. So here's one option, and this is the second option. I'm going to show you both. So let's stick with the first one first, and then I'll show you the other. So natural log x is the first function, and the second function is 3 minus x. I'm going to graph them on the standard viewing window in the hope that they intersect. They do. Now, careful here. We know that this function doesn't start here. This is a vertical asymptote, so the graph is this. So this is lying to us. It's not stop here or it starts here, right? The graph is this. Okay, so this is the intercept. So now, I go with second and calc. And from this menu, I'm going to use number 5 because I want to use the intersect. So I use 5. It's going to ask me, you're going to see a cursor, and it's going to ask you, is the blue function the first curve? I'm going to say yes, enter. It's going to jump to, please, yes.
You have to click over, because it's picking it up on the vertical asymptote. You have to click like the over arrow. Unpack it down. Right, right, you're right there.
The arrow.
Yeah. There you go.
Oh, okay, first curve. Okay, this is this. But this is my second curve.
Click down. Click it down. And click to the right. There it is.
Okay, that's my first curve, yes. Okay, it should jump by itself, and it does. Okay, very good, thank you. So that's my, and I don't want to guess. Or if you want, you can guess. I'm going to guess 1, 2, 3. I'm going to guess 3. So you should give me the intersect, which is a 2.2079, and the y values have to be the same because that's the same height here for both functions, blue or red. So I write x equals 2.2079, approximately. Now here's the other option. So go back to y equals, clear both, just clear the second one, or just de-highlight it. I'm going to de-highlight the second one. Okay, and then I have, careful, we move everything to one side, so it's -3 and plus x. And now we go to second, and I'm not second, I'm sorry, and tape and graph. So it's graphing you the combined function.
You had plus x, which should be minus.
You know, the problem is that I put the wrong minus. That's why. I said, oh, how come? How come that this function is 2 intersects? You can only have 1. We found the solution. Good. So now I'm going to, instead of using the intersect, I'm going to use the 0 feature. The 0 of the function, where the function is 0 or the x-intercepts. So I'm using 2 this time, and it's asking me for a left bound. I'm going to say the left bound is 1. I'm going to say the right bound is 3. And no, I don't want to guess. Just give me the number, and it's 2.20794, and y is 0. Is this clear? Do we understand the difference between the two? With one of them, you use the intersect feature. With the other one, you use the 0, the x-intercept. That's the difference. Anything else here before we look at word problems? Is there anything else?
We saw one of those inequalities. That's what we should.
Yes, of course. Please choose. Yes, of course. We have to remove him from class. That's what it is. It's the only chance we have.
It doesn't matter.
So which one? X. Very good. Good pick. 339. So we have x squared e to the x minus 2 e to the x less than 0. Perfect pick. Actually, we should do more of these high-end type of problems because of your next steps in math. And I know you told me this is your last one. That's why you're torturing us.
Yep.
No, I'm kidding. Okay, well, obviously, this is an inequality that has two terms, and they both have e to the x. So I have to pull out e to the x. Did I copy the problem correctly?
Mhm.
Yes, okay. Good. Now, I'm asking myself, what type of number is e to the x?
It's the natural number.
Yes, right. But remember, if it's e to the x, not e to the x minus 5, yes. So what type of number will always e to the x? Pure e to the x. Right. Greater than 0. Right. So it's a positive number. So this positive number will not affect the result. Right? For this whole thing to be negative, this has to be negative. Because this is always positive no matter what I do. So then from here I know that x squared minus 2 has to be less than 0. So the whole inequality reduces to solving a quadratic inequality. And you can say, well, how do I factor this? Well, we normally don't think in terms of factoring this, but we can. It's x minus the square root of 2 and x plus the square root of 2. Right? First term squared minus the second term squared. And then, yes, I can use the chart for x minus the square root of 2, x plus the square root of 2, and the product. Which numbers go in the chart? Well, two numbers, and they are negative the square root of 2 and the square root of 2. So there is a 0 for x plus the square root of 2 here, and there is a 0 for this, and a 0 here, and a 0 here for the product. Well, there is no problem. Both of them have positive slope, so negative and then positive, negative and then positive. And then I know for the first, on the first interval, I multiply two negatives. What do I get? Correct. In the middle, I have a negative, and outside. So only now I'm asking myself, what will I pick?
Between negative square root of 2.
Right, exactly. So x in the interval, negative the square root of 2 and the square root of 2, indeed. Now, 69 is an interesting problem. If you want. If not, we go to more problems. Okay, let's look at 69. It's a fun problem. We talked about something similar a while back. Not in this context. Well, we have never seen this before. This is an exponential inequality. I can't even look at anything before I graph this function. So I have to graph it. Well, I know how it looks. It has a base greater than 1. Looks like e to the x. Looks like 2 to the x. So it's something like this, right? So this is 10 to the x. And this is somewhere I have here 2. And somewhere here I have 5. Correct? So then I have to determine this. And then I have to determine this. When x, well, I shouldn't put 2 and 5 there. I have to have them here, sorry. 2 to the x between 2 and 5. Which I don't have are the x values. Those I don't have. So I am told 10 to the x is between this line, y equals 2, and this line, y equals 5. And the question is, what is x? So how do I determine that? Is by solving the equation 10 to the x equals 2. And then solving the equation 10 to the x equals 5. and then putting those numbers here. How do I solve 10 to the x equals 2? 10 and 2 cannot be presented with the same base. So there must be the other mechanism. What mechanism? Apply. Exactly. I need a mechanism that brings x down. Log of 10 to the x equals log of 2. And I bring x down and I get x, because log base 10 of 10, common log of 10 is 1. Very good. And then in the same way, I get the other one, log 5. So then this number here is log 2, and this number here is log 5. And I solve the inequality. So where should x be if 10 to the x has to be between 2 and 5?
Between log 2 and log 5.
Exactly. Very good. Okay, so let's look at a couple of word problems before we look at the last section, 4.6. Compound interest, doubling an investment, interest rate, radioactive decay, skydiving, fish population, cooling an engine, transparency over lake, electric circuits, atmospheric pressure. Let's look at one or two. Yes, doubling an investment. Very good. So let's take a look. So that is problem 79. How long will it take an investment of $1,000 to double in value? If it doubles in value, what is that going to be? So how long it takes if we deposit $1,000 today to get $2,000 back, knowing that we are given the interest rate is R equals 0.085 per year, compounded continuously per year. Continuously compounded. So if you remember the formula for continuous compound interest, A equals P times E to RT. The accumulated value, it should be, to be exact, it should be this, to indicate that P is the principal, E is the number, R is the interest, T is the variable in the problem. But sometimes it's not T, the variable in the problem, so that's why they did not really make it as a function of T. I understand why. Good. So what is the accumulated value? Excellent. What is the principal? E, the interest rate, 0.085 times T. Good, so what do I do next? Careful. I have to divide by 1,000. I have to clean it up. Yes, so when I divide by 1,000, I get 2 equals E to 0.085 T. Now, I do what? Yes, the reason why I apply log is because E and 2 are not the same base. But if I have the same base, it's a waste of time to apply log, because it's much easier than that. If I have two numbers that have the same base, the exponents have to be the same. So then natural log 2 must equal 0.085 T times natural log E, which is 1. So then T equals natural log 2 over 0.085. Natural log 2 divided by 0.085. So in a little bit more than 8 years, 8.15. So T approximately 8.15 years. Good. Anything else before we go on to the last section? '83, the fish population, skydiving, radioactive decay. Okay, fish population. A small lake is stocked with a certain species of fish. The fish population is modeled by the function. So this is 83 on page 339. P equals 10 divided by 1 plus 4 times e to negative 0.8 t. Did we do this problem? Okay. Where p is the number of fish in thousands. And t is measured in years since the lake was stocked. Okay. Perfect. Find the fish population after 3 years. So again, this function should be, this is the correct notation. Right. So in question number 1, we're asked to find the fish population after 3 years. What will I have to do? Right, of course. So P of 3. So it's 10 over 1 plus 4 e to negative 0.8 multiplied by 3. Don't try anything by hand. So 10. Since there is only one term at the top, there is no need of parentheses, but you have to have parentheses around the denominator. 1 plus 4 e to, in parentheses, negative 0.8 times 3. Close the parenthesis and close the parenthesis for the denominator and hit enter and you will get 7.34. 337 I should write. What does this mean? Right. So I'm just going to put a comma then. Fish. So 7,337 fish in 3 years. Perfect. Now, part B. After how many years will the fish population reach 5,000 fish? How do I address this? Right. Exactly. So 10 equals 5,000 and in parentheses 1 plus 4 e to negative 0.8 t. Now we have to be very careful, step by step. We have to clean it up. Okay, very good. So I have 1 over 500 then. I simplified by 10. It's not cleaned up yet. Yes, very good. So then I have negative 499 over 500 equals 4 e to negative 0.8 t. 1 over 500 minus 1. Let me write on the side. 1 over 500 minus 1 is 1 over 500 minus 500 over 500, which will give us negative 499 over 500. I have no choice. But division by 4 is better if I imagine it as multiplication by 1/4. So negative 499 over 2,000 equals e to negative 0.8 t. And we got carried away. And we forgot something very important. And we got to a point in which we're stuck because I cannot apply natural log to the left-hand side. How come that I cannot apply natural log to the left-hand side? Because it's a negative number. Right? I cannot apply it here. So then I remember that the fish pop, the P is in thousands. And they told us 5,000. And we put in 5,000 instead of 5. That's how I realized that something was wrong. Because I got here and I said, oops. Here I can apply log, but I cannot apply it here. Something must be wrong. And then here it is. I wrote it, but I forgot about it.
Yeah, we came back with angry scribbles.
Exactly. So I had to write sorry. So this is only 5, not 5,000. So we have to start from scratch on part B. That's how we learn. Okay. So then I have 5, quantity 1 plus 4e to negative 0.8t equals 10. Totally different story. And now what? Right. So it's 1 plus 4e to negative 0.8t equals 2. And then we'll go back and check, right? There's no problem there. Yes. So we have 4e to negative 0.8t equals 1. And finally, e to negative 0.8t equals 1/4. Totally different story. Can I apply log now to both sides? Excellent. Actually, it was a very good mistake. It taught us not to forget we cannot apply log to a negative number. Okay, so now we apply natural log to both sides. The left-hand side is negative 0.8t, and the right-hand side is natural log of 0.25. Or 1/4, doesn't matter. So t equals natural log of 0.25 divided by negative 0.8. So we know one thing for sure before we even look at the calculator, that the answer must be right, exactly, because it's time, it has to be positive. Excellent. Good. So let's plug it in. So where am I? So natural log 0.25. Hey, natural log 0.25 divided by, in parentheses, negative 0.8. Good. So in roughly 2 years. So now I would like to go back, and if you want to, we can check and plug it in here with the previous answer and see if I get 5. So I will say 10 divided by, in parentheses, 1 plus 4e raised to negative 0.8 multiplied by the previous answer, the whole thing, and then close the parenthesis for the denominator, and the answer has to be 5, which means 5,000. Very good. Well done. We want to look at something else like radioactive decay. Yes? Perfect. We're going to have more problems with this in the next section. Radioactive decay, 81 on page 339. A 15-gram sample of radioactive iodine. So mass, 15 grams. And this is normally denoted by